Alright, linear equalities in two variables. We're talking inequalities, and so we don't have equal signs anymore. So what that means is we're going to be shading. Because whenever you have inequalities, you can't represent it with just a bunch of points. The solution to systems of equations is it just had a point x, y. But we're not going to be able to list all of the points. So let's graph. So 2x plus y is greater than 1. So that means y is greater than, if we subtract 2x plus 1. Let's graph this. So I solved it for y so that we would have slope-intercept form. Y-intercept, slope. Down 2 and over 1, down 2 and over 1, down 2 over 1. You get the gist, right? Now, because this is just greater than, it doesn't actually include the line. And so what I want you to do is use a dashed line. Just like we use an open circle, use a dashed line when it's just greater than. Because it's greater than, I'm going to shade above. Some people use test points here. And I'm not shading very dark right now because I've got a second line I need to graph. Some people use a test point, say 0, 0. Zero is greater than negative 2 times 0 plus 1. So 0 is greater than 1. That's false. So you shade the other way. I like just popping it into slope-intercept form, and then you don't have to go about that. So because it's greater, y is greater, we shade above the line, because that's where all the bigger y's are. X minus y is less than or equal to 3, so this one's going to have a solid line compared to the other one, which was dashed. Negative y is less than or equal to negative x plus 3. The thing to keep in mind is the only rule with inequalities when you start solving is if you multiply or divide by a negative. We're going to do that here. Divide by a negative 1 or multiply by a negative 1, whichever you're fancy. And I ignored my rule. It's greater than or equal to. So 1, 2, 3. The y-intercept. Slope is 1. So you go up 1 over 1. And we have a line. Y is greater than or equal to. So again, we shade above. Where's the intersection of those two? They both overlap right here. And so that is your solution. Not one point. Not a bunch of points, but you could pick out 2, 1, 3, 2, 5, 5. There are infinite solutions to this, and that's why we graph it rather than start listing all of the solutions. Let's try another one. Remember that one was dashed, one was solid. So now we have a system, and we have a system of 3 equations. X is less than 6. That's a x, so we go 1, 2, 3, 4, 5, 6 to the right, and that's a vertical line. So less than, I'm going to use a dashed line, and I'm going to shade less than. All of the x's that are less than are this way. X plus y is greater than 4. So if I solve that for y, y is greater than negative x plus 4. Y-intercept of 4. 1, 2, 3, 4. Slope of negative 1. So down 1 over 1. Again, I'm going to use a dashed line because it's just greater than. And because it's greater than, I'm going to shade. So right now the overlap is happening right here. Shaded this way, shaded this way. And y is less than negative 1/2 x plus 4, so we have the same y-intercept. The slope is negative 1/2, so we go down 1 over 2, down 1 over 2, down 1 over 2. And you could go back this way if you wanted to, up 1 over 2, up 1 over 2. Again, it's just a dashed line. It would be solid if it was the or equal to. And this one is less than, so we shade below the line. And so the overlap is right here, because we shaded to the left of the vertical line, we shaded above the second line, and shaded below the third line. And so this is our solution set right here. Congrats! You made it through graphing systems of inequalities.